Hello children, welcome back to my channel. Today we are going to learn about hydrated substances and anhydrous substances. So let us first discuss about hydrated substances. In our day-to-day life you can see some of the substances are associated with a fixed number of water molecules, and these water molecules are an integral part of the compound. For example, you can see blue vitriol, whose chemical formula is CuSO4.5H2O. This 5H2O, they are integral part of the compound copper sulfate. And this type of substances which contain water of crystallization as an water molecule as an integral part of the compound are known as hydrated substances. You can see we know many examples of hydrated substances. Blue vitriol, green vitriol, washing soda, these are some of the examples of hydrated substances. Now these water molecules which are associated with the compound, they are known as water of crystallization. Now why they are known as water of crystallization? It is because due to the presence of these water molecules, the compounds are crystalline. They exhibit crystalline characteristic, and these small particles are known as the individual molecules are known as crystal. So what is a crystal, what is crystallization, and what is water of crystallization, we will discuss in detail. Now what is a crystal? Crystal is a homogeneous substance having a regular geometrical pattern throughout the compound. Crystalline substance or crystal, it is a compound having a regular geometrical shape throughout the compound, and that is known as crystalline substance. Some of the substances maintain this geometrical pattern, geometrical shape, and they are known as crystalline substances. And most of these substances, they are hydrated substances. They are hydrated substances. Some of the crystalline substances we will see. First one we can see crystalline substances like blue vitriol, green vitriol, red vitriol, all these are crystalline substances, and also they are hydrated substances. Here one thing I want to say you, that all hydrated substances are crystalline in nature, but all crystalline substances are not hydrated. There is a process known as crystallization, in which we can obtain large crystal from small powdery substances. Suppose you take some powder of copper sulfate, then this powder, you cannot study the geometrical shape, the geometrical shape, and that one cannot be studied using this powder. Now to obtain crystal from these powdery substances are known as crystallization. To obtain the crystal, large crystal from this powdery substances are known as crystallization. So crystallization, we can say, it's a process by which crystal of a substance are obtained from its powdery form. So first one, crystal is over. Crystal is a homogeneous solid of definite and regular geometrical shape. Now crystallization is the process by which you obtain crystal from its powdery form. Now how can we obtain this crystal? There are different methods. 4 methods we will see. The first method is by cooling a hot saturated solution. You have to prepare a saturated solution at a higher temperature, and when we slowly cool it, then we will get crystal of that substance. So the first method is by cooling a hot saturated solution. Second method we can say by slowly evaporating a saturated solution. When we prepare a saturated solution and slowly evaporate the solvent will be, extra amount of solvent will be evaporated, and slowly the crystals of the substance reappears in that solution. Then by cooling of fused mass or molten mass, when a molten mass is cooled, then also we can get crystals. That is also a process of crystallization. And finally, by sublimation also some of the substances can be crystallized. So these are the four ways by which we can obtain crystal from the powdery substances. So this is about hydrated substances or crystalline substances. Okay. Now let us come to anhydrous substance. Some substances, they do not contain water of crystallization, so they are known as anhydrous substances. Now you can see, suppose CuSO4 5H2, which we say blue vitriol. Now blue vitriol is heated, then this 5 water molecule escapes, and you can see that some white substance is present. Now the blue color also disappear, and the crystalline nature of blue vitriol also disappear. And when we see this one, then we can say the remaining residue, which is a white color amorphous powder, whose chemical formula will be CuSO4, is anhydrous copper sulfate. Now you can understand, when we heat a few crystal of copper sulfate crystal, then you can see two observations. First one, the crystalline nature of the substance disappears, and second one, the color also changes from blue to white. These are the two observations when copper sulfate crystal or blue vitriol is heated. Now from this, what we can say, the crystalline nature of blue vitriol is due to the water of crystallization. Once they escape, then the crystalline nature also disappear. So my dear student, that is the reason these water molecules are known as water of crystallization. Another thing also I want to tell you, because of this water of crystallization, you can see the substance do not become wet. It remain dry, and that is why I said it is an integral part of that substance. Okay. Now hydrated substances example already I gave you, that is washing soda, its formula is Na2CO3. Then green vitriol, its formula is FeSO4.7H2. So here I want to show you a list of hydrated substances on your screen. You can see I am showing you a list of hydrated substances on your screen. Now, anhydrous substances. Substances which do not contain water of crystallization. Compounds which do not contain water of crystallization are known as anhydrous substances, like sodium chloride, potassium nitrate, sugar. All these are example of substances which do not contain water of crystallization, and they are known as the anhydrous substances. Okay. Now there are some property we can see related to this water of crystallization and hydrated substances. Water of crystallization and hydrated substances. Some of the property we can see. First property I want to tell you is efflorescence. What is efflorescence? Efflorescence is a phenomenon where a compound loses its water of crystallization spontaneously or automatically. We need not do anything. If you keep the substance, hydrated substance, outside, exposed to the atmosphere, then the water of crystallization it escapes either partially or wholly. All water molecules can escape, or a part of the water molecule may escape in this process. So this process is known as efflorescence. Suppose, for example, you can see, suppose if you keep some washing soda outside, exposed to the atmosphere, after some time you can see the crystalline nature of washing soda disappears, and slowly you will get a powdery substance which is known as soda ash, whose formula is Na2CO3 without water of crystallization. So this process is known as efflorescence. Now, some substances, they shows efflorescence. They are efflorescent substances and they lose water of crystallization automatically when exposed to the atmosphere. This is a property of the hydrated substances. For example, washing soda, already I told you. And another example also I want to give you, Glauber salt. Glauber salt, the formula of Glauber salt is Na2SO4.10H2O, decahydrate sodium sulfate. So these two are example of efflorescent substances. Now, efflorescence, when we study this property, then under what condition rate of efflorescence, rate of losing the water of crystallization is high. So children, I want to tell you there are two conditions in which the rate of efflorescence increases. First one, if the atmosphere is dry, there is low humidity and there is a dry atmosphere, then the rate of efflorescence will be more. And second one is when the temperature is high. At high temperature, rate of efflorescence is more. So rate of efflorescence increases when the atmosphere is dry, having low humidity and a high temperature. Dry and hot atmosphere, rate of efflorescence is more. Okay, now let us move forward. The second property I want to discuss is deliquescence. What is deliquescence? We can consider deliquescence as just the opposite of efflorescence. Just the opposite of efflorescence means loss of water of crystallization. Now, deliquescence is absorption of moisture from the atmosphere. Deliquescence is absorption of moisture from the atmosphere, and by this process the substance turn wet and turn into a solution. Is that clear? Let us take one example. You might have seen, if you are keeping some sodium chloride exposed to the atmosphere, then slowly you can see the common salt get wet and it turns into a saturated, as if someone poured water onto it. Why? It is because common salt contains some impurities like zinc chloride, magnesium chloride, which are deliquescent in nature. That means they absorb moisture from the atmosphere and becomes wet and turn into solution. So this is deliquescence. Some of the example of deliquescent substances: caustic soda, highly deliquescent. Caustic soda, the formula is sodium NaOH. Then caustic potash, KOH. Magnesium chloride, as we discussed now. Zinc chloride. Then calcium chloride. Ferric chloride is highly deliquescent. So these are example of deliquescent substances. But remember, NaCl, pure sodium chloride, is not a deliquescent substance. Okay. Now, another related property we will see, that is known as hygroscopy. Now, what is hygroscopy? When someone asks you, it is very related to deliquescence. Here also you can see a substance when exposed to the atmosphere absorbs moisture. Here also it absorbs moisture. There is one difference only. Hygroscopic substances do not turn wet and they do not form solution. They do not change their state. Deliquescent substances, after absorption of moisture, they dissolve into it and form a solution. But hygroscopic substances, they remain dry. They do not change their state and they do not get wet. So hygroscopy is the phenomenon of absorption of moisture from the atmosphere by a substance without changing its state. Okay. Some of the hygroscopic substances example I want to give you: concentrated sulfuric acid, phosphorus pentoxide, quicklime, silica gel. This silica gel you might have seen in the packing of electronic appliances or machinery. There is a small packet written as silica gel is kept, so that what is its work? It will absorb moisture inside the box, and the machinery do not get affected by moisture. Okay. Now we will see what is a drying agent. Hygroscopic substances can be used as a drying agent. What is drying agent? Drying agent is a substance which is used to absorb the moisture from another substance and from the surrounding, to keep the surrounding dry. So we can use a drying agent to remove moisture from the gases or liquid or even solid substances. We can use a drying agent. So drying agents are nothing but the hygroscopic substances. Okay. One of the example we can see that anhydrous calcium chloride is used to dry hydrogen gas. If you have some moist hydrogen gas plus moisture, then you can keep some calcium, anhydrous calcium chloride there, so that it will absorb the moisture present along with hydrogen and renders hydrogen gas. Okay. Similarly, phosphorus pentoxide, magnesium sulfate, sodium sulfate, these are example of drying agent. These drying agents are also known as desiccants or desiccating agent. Another similar, it seems similar but not similar, term is dehydrating agent. So what is dehydrating agent? Here also you can see it is these substances remove water molecule, dehydration, that means removing water molecule. But the combined water molecule, they remove chemically combined water molecule. Dehydrating agents, when they are used, they can remove the chemically combined water molecule. Okay, that means it results in a chemical reaction. Drying is a physical process, but dehydrating is a chemical process. Now you can see one of the example I will give you. Now take some copper sulfate crystal and add concentrated sulfuric acid to it. Now concentrated sulfuric acid is a strong dehydrating agent. So it can remove the chemically combined water molecule present in copper sulfate crystal. That is the water of crystallization. So it removes the water of crystallization, and you can observe also the blue color fades and it becomes white. The blue color becomes white because of concentrated sulfuric acid. So this is known as dehydrating agent. So my dear student, today in this lesson we learnt about hydrated substances and anhydrous substances. Hydrated substances are those substances which contain a fixed number of water molecule known as the water of crystallization. But anhydrous substances, they do not contain water of crystallization. Also we learnt about some property involved in these hydrated substances, that is efflorescent, losing water of crystallization automatically, deliquescence, absorption of moisture from the atmosphere and turning into a solution, hygroscopy, absorption of water or moisture from the atmosphere without changing its state. Then also we learnt about drying agent and dehydrating agent. Thanks for watching my video. If you like my video, then please comment, like, comment and share. And to get the videos related to high school science, you can subscribe my channel right now. And you can press the bell icon, because if you don't press the bell icon, you may not get my latest update. So thank you. Bye bye.